All right, we're jumping into 5.5. It says a few lessons ago we discovered that the properties of parallelograms and then squares, rectangles, and rhombi. Why did squares, rectangle, and rhombi all have the same properties as parallelograms? Well, that was because they're all parallelograms. Just like a dog and a cat are going to have the properties of a mammal because they are both mammals. I have several examples of parallelograms, squares, rectangles, and rhombi. Use your observation to answer the following questions. Remember, while many of the figures may have the characteristic, you're trying to find out what figure it must be, not what it could be. So it says a parallelogram that has a right angle. Okay, so a rectangle has a right angle, and a square also has that right angle. Now, a square needs to have more than just the right angle, so that means that the most specific we can get is just the rectangle. We cannot say it's a square. Could be others, but it must be a rectangle. The next one, a parallelogram has both opposite congruent angles. While all of them have that, the only thing this guarantees that it is going to be a parallelogram. This must be a parallelogram. Okay. A parallelogram has perpendicular diagonals. Well, the things that have that are a rhombus and a square. A square needs to have more than that, so this must just be a rhombus. It's not enough information to push it to being a square. A parallelogram, move it up. A parallelogram has diagonals that bisect both angles. Well, that could be a rhombus and a square. We don't have enough to push it to being a square. With that information, if you tried to draw something, you might end up with a square, but you definitely would end up with a rhombus. A parallelogram has two adjacent and congruent sides. What is the most specific name for this? Well, it would be a rhombus. Okay. Well, a square also has that. A rhombus is going to be guaranteed to have that, whereas a square is going to have that, but it's going to have other characteristics that make it more specific than a rhombus. A parallelogram has diagonals that bisect one another. That is true for all parallelograms, but having that information just gets us to the point of knowing it's a parallelogram. A way I'd like to explain this is if I said the animal gives birth to live young. Well, you know a human does. That is only enough information to get us to saying it's a mammal. All mammals, you'll be able to say, do have that, except for the duck-billed platypus. I think that that is one that does not, and maybe there's something else. But my point here is just because it has that characteristic, like Paul or whatever, let's say a specific human does give birth to live young, but that's super specific. If I said it gives birth to live young, the furthest you could go is saying that it's a mammal. Okay. Let's go to the next one. A parallelogram has diagonals that are congruent, while a rectangle and a square have that. This only gets us to the point of knowing that it has to be a rectangle. Okay. Next one. A parallelogram has perpendicular diagonals. Okay, that's a rhombus, and it also has a right angle. That's a rectangle. So this has something from rectangle land and rhombus land. So that means it must be a square. It's definitely going to be a square. Okay. Now, here's what we got. If you want to prove something's a parallelogram, there is what you can prove it by one of those 6 ways. A lot of times I'm going to already tell you that it's a parallelogram and you'll be able to skip this. If you want to prove it's a rhombus, you can do that by saying two adjacent sides are congruent, diagonals are perpendicular, diagonals bisect both angles. If you want to show that it's a rectangle, it's either going to have, you can do that by showing it as a right angle or the diagonals are congruent. And if you want to show it's a square, then it's going to be one of each of those things. Now, on your check your understanding, it says if you had 3 shirts, 4 pairs of pants, and 2 pairs of shoes, you would have 3 times 4 times 2, 24 possible outfits. Use this reasoning, which is the fundamental counting principle, to figure out how many ways you can make your way to knowing that a figure is a quadrilateral to being a square. Think for a quadrilateral to be a square, it must be 3 different things. How many ways can you show each? Well, it's got to be a parallelogram, 6 ways. Rhombus, 3 ways. Rectangle, 2 ways. 6 times 3 times 2 is 36 ways. There's 36 different paths to going from a 4-sided figure all the way to saying it has to be a square. Now, looking at this, it says, what is the most specific name for the following parallelograms? I'm already telling you it's a parallelogram. You can skip having to show that it's one of those 6 ways. Justify your answer. Ignore that all look like squares. So the first one has diagonals that bisect one another. That's just making sure it's a parallelogram. And then it has two sides that are adjacent and congruent. That makes it a rhombus. So this is definitely going to be a rhombus. Doesn't have enough to push it all the way to being a square by showing it's a rectangle as well. The next one shows that the diagonals bisect the angles. That makes it a rhombus. While a square also has that, this only gets us, ooh, another mess up on my key. Beyond the diagonals bisecting both angles, which makes it a rhombus. 45 and 45 also make 90, so it's got to be a rectangle as well. And if it's a rhombus and a rectangle, it's got to be a square. So once again, I'm going to have to fix my key. This happens pretty much every single time. So this should make you feel good about making mistakes. I make these actual notes, and then I still make a mistake making the key to my own notes, which is kind of funny. The next one, diagonals bisect both angles. It's a rhombus. And it also has adjacent sides or all sides that are congruent. That's a rhombus. Double rhombus just keeps it as a rhombus. It's like me saying the animal is warm-blooded. You're like, mammal. And I'm like, it also gives birth to live young. Mammal. That didn't push it to being anything more specific than a mammal. The next one, diagonals are perpendicular. If the diagonals are perpendicular, it's going to be a rhombus. And then since the diagonals are congruent, which is on the bottom, that's a rectangle. Rhombus rectangle makes a square. The next one is showing both opposite angles are congruent. That is true for all parallelograms, and that can't get us any further than just saying it's a parallelogram. Next one, the 40 and 40 are not helpful. That's just like going to show the top and bottom are parallel, which we already knew because I said it was a parallelogram. And then you have the diagonals are congruent. That makes it a rectangle. The next one, you have a 3, 4, 5 triangle, which means it's going to be a right angle, right triangle, and it's going to be a rectangle. The next one, diagonals are perpendicular, rhombus. You also know the diagonals bisect the angles, rhombus. You also know two adjacent sides are congruent, rhombus. And a rhombus, rhombus, rhombus is just a rhombus. So the only one I messed up on was B. Good for me. Woohoo. So I need to fix my key. B is supposed to be a square. Now it says Peter has a quadrilateral that is bisecting diagonals. That's a rhombus. Perpendicular diagonals, rhombus, and two adjacent congruent sides. That's a rhombus. And then, so the diagonals bisecting one another is just a parallelogram. So it's a parallelogram, it's a rhombus, rhombus, rhombus. So it's just, there's nothing showing that it's a rectangle, so we can't push to a square. It's just going to be a rhombus. The next one, explain why the parallelogram can't be a rectangle. Ignore that it looks like a rectangle. Well, 5 squared plus 12 squared does not equal 15 squared, so it is not a right triangle, it is not a right angle, and therefore it cannot be a rectangle. Next, give a single 3-step method to showing that a quadrilateral is a square. Well, first you would show it's a parallelogram, and you guys should have written down one of the 6 ways from the quick notes in that place. Next, show it's a rhombus or a rectangle. If you said rhombus, there were 3 ways. If you said rectangle, there are 2 ways. And then you would say, then show that it is the one that you haven't already shown. So if you already said it was a rhombus, now show it's a rectangle. And then once you know that it's a parallelogram, rectangle, and rhombus, it's got to be a square. So there are many possible, there's actually 36 different ways you guys could have answered that. Normally, knowing diagonals bisect one another would only show that the quadrilateral is a parallelogram. Explain why the following shows that it's a rectangle. Well, not only are the diagonals bisecting one another, but together they are a 1 tick and a 1 tick. They're 2 1 ticks for one length, and the other one is 2 1 ticks. So if they're both the same exact length, then the diagonals are congruent, and that means that it must be a rectangle. Okay. And once again, let's see. You know, the diagonals bisect one another, which makes it a parallelogram, and then they're congruent, which makes it a rectangle. Next, John gets confused when he hears quadrilateral using diagonal. When he hears that a quadrilateral has diagonals that are perpendicular, he states that it must be a rhombus. If he already knew that the figure is a parallelogram, then he would be correct, but he did not know this yet. Give an example of another quadrilateral that has perpendicular diagonals that is not going to be a rhombus. So a kite If you draw a kite and you make the diagonals, you'll see that they intersect at right angles. So they are perpendicular, but that is not going to be a parallelogram. Okay. The next one, if you know that you have a parallelogram, match the reasons with the figures that the objects must be. Has a right angle, that has to be a rectangle. Has perpendicular diagonals, that's a rhombus. Has diagonals that are congruent, that's got to be a rectangle. Has diagonals that bisect both angles, it's going to be a rhombus. And then E has a pair of adjacent congruent sides, that is going to be a rhombus as well. And a square would have to have one from each. Now you might ask yourself, why does it only have to be two adjacent sides that are congruent to say it's a rhombus? Well, if it was already a parallelogram, then you know opposite sides have to be congruent. So if those two are congruent, opposite of them are also going to be congruent, and therefore all the sides will be congruent. Now let's go ahead and go through these. The first one, what does this have to be? This has to be a rectangle, because 30 and 60 make 90, and if it's a parallelogram already and has a 90-degree angle, it's a rectangle. The next one, you have the diagonal bisects the angles, it's a rhombus. You also have the adjacent congruent sides, that's a rhombus. Double rhombus is just a rhombus. The next one is going to be the slope of one of the diagonals is 2/3, the other one's -3/2. That means that they are perpendicular, and so perpendicular diagonals make it a rhombus, and it also has a right angle, which is a rectangle. And if it's a rectangle and a rhombus, it's got to be a square. The next one just shows that both consecutive angles are going to be supplementary. That's just to show it's a parallelogram. That doesn't push us anywhere beyond a parallelogram land. The next one is diagonals are congruent. When diagonals are congruent, that must be a rectangle if it's already knowing that it's a parallelogram. If it didn't know it's a parallelogram, it is not guaranteed to be a rectangle. It could also be an isotrep. And the last one, since 10 squared and 24 squared add together to be 26 squared, you know that that's a right triangle. If it's a right triangle, it's a right angle, and if it's a right angle, then it's a rectangle. All right, hopefully that made sense. There are 6 ways to show something is a parallelogram. Hopefully I already tell you it's a parallelogram. 3 ways to show it's a rhombus. 2 ways for rectangle, and a square, you have to have one of each. Thanks for watching.